at the end of level test, it says what trig ratios are correct, and you click on the ones that are correct, okay? Because it's a test on a computer. So first of all, couple things to notice. Everybody, first of all, the first thing you should notice is I have a right triangle, right? Yep. We know it's right because it's a 90-degree angle. So then you say to yourself, what do I know about right triangles? First of all, in secondary 1, you learn how to find missing side lengths, right? Side 1 squared plus side 2 squared is equal to the hypotenuse squared, the Pythagorean theorem, right? Then also in secondary 2 this year, we've learned right triangle trig ratios. There are 3 right triangle trig ratios: sine, cosine, tangent, right?
Right.
And we use that, if you recall, we used that to find missing angles, right?
Right.
And we used it also to find missing sides. Okay, so you would say to yourself when you see this problem, oh yeah, I know that the 3 right triangle trig ratios are sine of theta, cosine of theta. You would write this down because you're going to have scratch paper on the test. Tangent of theta. Sine, cosine, tangent, right, everybody?
Yes.
Then you say that's equal to what? And then you say you're saying, oh heck,
Another
hour of agony, which opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay. So let's go through and see which ones are true. So it says cosine of r is equal to 15 over 17. So first of all, my question is, cosine we know is adjacent over hypotenuse, right?
Right.
But you need to pay attention to one other thing. What angle are we going off of? R. Does everybody see how there's an R there?
Yeah.
So you gotta go to angle R. So this is the angle we're going off of. Does everybody understand that?
Right.
So cosine is adjacent, which is 15 over hypotenuse, which is 17, right? So this one we would click on. Is everybody good with that?
Right.
Moving on to the next one, sine of R. Angle R. We're still staying at angle R. Sine is opposite over hypotenuse. So opposite 8 over hypotenuse, which is 17. Was that one true? Yes, so we clicked on it. Tangent of R. Notice, you've got to look at your angle. We're also going up R. Tangent is of agony. Opposite over adjacent. Opposite over adjacent. Is everybody comfortable with why that's opposite, why that's adjacent?
Yeah.
Okay, 8 over 15. Also, we click on that. Okay, moving on. Now it says cosine of W. We're changing angles now, aren't we?
Right.
Okay, so we've got to look at angle W. Cosine is another hour. Adjacent, which is 8, right?
Yep.
Over hypotenuse, which is 17. Was that right?
No.
So we wouldn't click on that one. And then sine of W. So here's W. Sine is opposite over hypotenuse. 15 over 17. Yeah? And then tangent of W. So still a W is, and we'd refer back, we'd always write this down, opposite over adjacent. Okay, so opposite from W is 15 over adjacent, which is 8. How many got 100% correct? Awesome. How many of you see what you did wrong and won't get it wrong next time? Okay, good. Just as good. Okay, let's get going for what we're doing today. Okay? So 7-7, guys. So here we go. So today we're going to be finding the inverse of a function. That's what we're going to be doing is the back side of the worksheet. So we're going to be finding the inverse of a function. So if you have a function f of x and you want to find the inverse, this is how it's denoted, meaning this is the notation you're going to see. This f inverse of x. See that -1? That stands for inverse. So it reads f inverse of x. So you take a function f of x, you want the inverse. Once you found the inverse, it would be denoted as f inverse of x. Okay, so first of all, before we get going with this, you need to understand what an inverse of a function is. So the inverse of a function is a reflection over the y equals x axis. So now a lot of people might be thinking, what do you mean y equals x axis? Well, let's think about it. Isn't the form of a line y equals mx plus b?
Right.
So isn't this a line?
Right.
What's my y-intercept?
X.
No, what's my y-intercept? No, there's not a +1 out here.
0.
Isn't my y-intercept 0, guys? Right here?
Yep.
Okay? And then what's my slope?
1.
1. So we'd go up 1 over 1, up 1 over 1, up 1 over 1. Do you see how that pink dotted line is y equals x?
Yep.
Okay. So once again, the inverse of a function is a reflection over the y equals x axis. So guys, if we have this triangle, we take and we stamp it across that line, it's going to reflect across that line. Does everybody understand that? Is everybody good with that? Now let's say that I wanted to so let's say I give you xy points. How you can find the inverse of xy points is to flip xy and graph it. So you just switch x and y and then graph it. So look. If this, on this function right here, if we're at -4 up 2, The inverse would be over 2, negative 4. You see how I switched x and y? Everybody?
Yeah.
So over 4, negative 2.
Right there.
Okay? I said that wrong.
It's,
Sorry. Ignore that last statement. Over 2, negative 4, right? Over 2, negative 4. I was going to say, that does not match there. Does everybody see how they map evenly across the y equals x axis? Yeah? If we stamped it across, isn't that where it'd end up? Okay, next point. This is negative 2 up 4, right? Negative 2, 4. So the inverse of that would be 4, comma, negative 2, right? Everybody. Over 4, down 2. So does everybody see how it stamps evenly across there? We're all good. And then this point's at negative 5 up 4. So tell me, I'm not going to graph it, but what would the inverse be?
5, negative 4. 4, negative 5.
4, comma, negative 5. We just switch x and y. Does everybody see how that works? So if I gave you a picture on the test and said, what are these inverses? And I gave you this picture, could you look and see without the pink line? Could you say, oh, you know what? I know that an inverse is a reflection over the y equals x axis, right? And you could stamp it and look and see, okay? Then also I could say, is this an inverse? You look and see if the xy points are switched. Does everybody see that? Okay, now, so if you're given a picture, you can find the inverse. You switch x and y, graph it. It will be a reflection over the y equals x axis. Now we're going to be given a function, not as a picture, but as an equation, and this is how we go about finding the inverse. So here are the steps. You're going to want the steps. Okay, so these are the steps to finding an inverse. So I have my first example actually as we go through the steps here. So we're taking a function f of x and we are finding the inverse, f of x. So your first step is switch x and y. Isn't that what we did in the other problems?
Oh yeah.
Okay, so your first step is to switch x and y. So if we start out with the equation y equals x minus 2, our first step will be to switch x and y. Does everybody see how I've done my first step? Any questions on that? Do you see how I took this and switched x and y?
So we're not finding the...
We're finding the inverse, we're not done. This is the first step. We're finding the equation now. So does everybody see how my first step I switched x and y? Yes or no?
Yes.
Okay, second step. Once you've done that, so we're starting here, we're going to then solve for y algebraically piece by piece. So once you've switched x and y, your second step is to solve for y algebraically. So look up here. We have x is equal to y minus 2. How will you get y along?
Plus 2.
Add 2 to both sides of the equation, right? So this is our second step, solving for y algebraically. So we would have x plus 2 is equal to y minus 0, which is just y, right? Everybody? Yes. And you're done. Once y is alone, so do you see how y is alone? We have y equals a function, just like we did to start with, y equals a function. We have y equals a function right here, so our y is completely alone. We found the inverse. Our third step is just to write it in the proper notation. So our third step is just writing it, instead of a y, we took f of x and we found the inverse, so instead of a y, you'll write f inverse of x is equal to that. Does that make sense, everybody? Now, we have to be really, really good at algebra to do this correctly, okay? And a lot of people's algebra skills are clear down here, and to do these correctly, your algebra skills have to be through the roof. So I'm going to do quite a few examples right now. Watch, ask questions. You don't necessarily need to take notes during the examples, but you need to watch very carefully and pay attention to the algebra. Does that make sense? Smart and not make any algebra mistakes. Okay, so we're given the equation, we're asked to find the inverse. So my first step is to switch x and y, right?
Yeah.
So isn't this the same thing as a y? Everybody? Isn't f of x means we have a function of x? Isn't that what means y equals means? So we have y, right now we have y is equal to 2x plus 3. So now we'll do our first step, which is switch x and y. So we have x is equal to 2y plus 3. Does everybody see how I'm done with my first step? Now it's just algebra, as long as you do the algebra in the correct order to solve for y. Get y alone, algebraically, piece by piece. What would my first step need to be?
Divide by 2.
No, if we divide by 2, that would be incorrect first, because we can't just divide by piece by 2. So, good try. What would be the first thing we need to do? If we add 3, that's not going to work. That would give us a 6 over here. Good. So, what do we subtract 3 from both sides of the equation? So, over here on the left, we have x minus 3 is equal to 2y. Now check. Make sure your inverse is added up correctly. Does that add up to be 0? So we're good. Does everybody see? I'm not going to write plus 0 there. Are we all good with that? Okay. Now to solve for y, now what can I do? Good. 2 is multiplied to y. What undoes multiplication, division? So when we divide now both sides by 2. Yeah? Is everybody comfortable? So over here on the left, I have x minus 3 all over 2 is equal to, what's 2 divided by 2? What's 2 divided by 2? It's not y. 1. So we have 1 times y, which is y. Now look, it's y alone. So we found the inverse. Well, you think it's funny, but people don't know that. They're like, oh, so that's why people will say, oh, 1 divided by 1 and comes 0, goes away. No, so that's why I'm going to talk about every step today. Does that make sense, everybody? Okay, so y alone. So we found the inverse. That is our inverse. We're going to write it in the correct notation. So f inverse of x was equal to x minus 3 over 2. Okay, questions? Okay, let's do another one. They're going to get harder and harder. Pay attention. Do not zone out today. I do this many examples because you need them. You really do. Okay, let's go through this one. So we have y is equal to 3x squared minus 1. And we're asked to find the inverse. Let's go through this correctly in the correct order. So we switch x and y, right?
Right.
So we have 3y squared minus 1. Algebraically getting y alone, first step.
Plus 1.
Add 1 to both sides of the equation. So we have x plus 1 is equal to 3y squared plus 0. Doesn't that add up to 0? So we've done it correctly, right? So now what will we do?
Square root it.
Ooh, if we square root it, what about that 3?
Divide by 3 first.
Yeah, we would need to divide by 3 first, right, everybody? Because we can't just square root just a teeny piece. So we've got to do the exact same thing to both sides of the equation. So just 3 is multiplied to y squared. So what undoes multiplication, division? So we have x plus 1 all over 3 is equal to 1y squared, right? Which is just y squared. Does everybody understand? Y is still not alone. What's the inverse of a square? Square root. Good. So we could square root as long as you do it to both sides of the equation. So on the left, I have the square root of x plus 1 all over 3 is equal to square root and square cancel out until we have a y. Right? Isn't y alone? So that's our inverse. F inverse of x is equal to that. The square root of x plus 1 all over 3. Questions? Next one. Stay with me, guys. Do not zone out. Okay, here we go. So we have y is equal to 2x cubed plus 2 divided by 3. Switch x and y. X is equal to 2y cubed plus 2 all over 3. Okay, let's solve for y algebraically. What would you say? My first step is think very carefully about this. Okay, so I hear 2 good things. I hear, yes? Okay, good. So, yep, you're saying the same thing as him. So, let's think about this, guys. Can we subtract 2 first? No, because that's really 2/3, isn't it? Isn't that really 2/3? So we wouldn't do that. Let's take care of that. All of that being divided by 3. What undoes division?
Multiplication.
So I'm going to multiply both sides by 3. So we have 3x is equal to, now look, what's 3 divided by 3? 1. What's 1 times anything? No, what's 1 times anything?
1.
Anything, good. 1 times anything is just itself, good. So over here we have 2y cubed plus 2. Is everybody comfortable? Okay, let's solve for y algebraically. Next step.
Minus goes.
Minus 2. So we have 3x minus 2 is equal to 2y cubed.
What do you do?
Now what do you do?
Square root.
Not quite. What do we need to do first?
Divide by 2.
Isn't 2 being multiplied to y cubed?
Gosh.
Wouldn't we need to take care of that first?
Can't you get
So we would divide both sides of the equation by 2. So I'm going to come up here. So we have 3x minus 2 all over 2 is equal to 1y cubed, which is just y cubed. 1 times anything, just itself. What undoes a cubed power?
divide by 6?
Cube root. Who said that?
Right.
Cube root. Good.
Right.
So what undoes a cube power? A cube root. If you can't write square root, that's wrong. Isn't it a cube root? So it's a cube root. So over here on the left, we have cube root of 3x minus 2, all over 2, is equal to the cube root and the cube power cancel out. And that's our inverse. I'm not going to write f inverse of x because I don't want to take the time. Questions?
We write inverse.
No. You can do it. Okay, couple more. Stay with me. You need them. I didn't do a couple with my first hour and I had to come back and do them. Okay? Here we go.
No, I'll just ask you for you guys.
Okay. Switch x and y. So I'm going to skip steps on this one so we can go a little faster. So this will be a x, right? X is equal to the square root of y minus 7 plus 5. Is everybody comfortable?
Minus 5 first, yeah.
Good. So we would need to subtract 5 from both sides. So we have x minus 5 is equal to the square root of y minus 7. Okay, guys. So if you don't think your algebra, if you think your algebra skills are better than first hours, I'll stop and let you just go.
Square root of
Are you gonna? Do you want me to continue? Okay. Then I need you listening. Okay. So then what? How do we? Is it y minus 7 trapped under the square root?
Yeah.
So what? Square root doesn't undo a square root. What does?
Square. By 2.
Good. Square both sides. Now, if you're squaring both sides of the equation, wouldn't you have to do the full side?
Oh, yeah.
So we need parentheses, right?
Yeah.
So we have x minus 5 squared is equal to, root cancels out with power left is y minus 7. Last step. Can I add the 7 in with the 5?
Nope.
No, right? Isn't that in the square?
Yeah.
What's 7 in the square?
Nope.
No, you can't put them together then. So we have x minus 5 squared. We have a plus 7 out here, right? You can't put it in. Is equal to y. And then isn't y alone? There's our inverse. Questions? I know you're anxious to start. Couple more.
Let's go. Get it.
So we switch x and y. So we have x is equal to y minus 1 to the 4th plus 3. What's my first step? Minus 3. X minus 3 is equal to y minus 1 to the 4th. What undoes the 4th?
4th square root.
So let's say it right, you're right. But let's say it right, it's not a square root, it's a 4th root.
4th root.
4th root. Let's all practice it. 4th root. One more time. 4th root. Okay? So then we have the 4th root of x minus 3, that's all under the 4th root, is equal to y minus 1, right? What will we do? Can we put the 1 under here? So we have the 4th root of x minus 3 plus 1 is equal to y. And that's our inverse, okay? Yes. Yes. Okay, last couple. Stay with me, guys. You need them. I promise.
Yeah.
It's hard stuff. Okay, this is probably the hardest one on there, and I'm going to teach you a trick. Okay? So, hardest one on there for sure. Okay, let's go. So we switch x and y. We have x is equal to negative 2 over y plus 1 minus 7. Stay with me. If any of them you listen to, it's that you need to have it be this one. Okay? What's my first step, guys? Add 7. We have x plus 7 is equal to negative 2 over y plus 1. Now notice something. Isn't that y plus 1 in the bottom of a fraction?
Oh, yeah.
Now here's what students tend to do. They say, okay, I'm going to multiply by negative 2 to both sides. Wrong. That would give us a 4 over here. Didn't that just make it worse?
What about negative 2 divided by 1? No, that's not.
You're on the right track though. Now because, okay, here, let me give you a trick. This is the easiest way to do this one. There's like 10 different ways algebraically to go about solving for y. Here's the easiest. As long as you do the same thing to both sides of the equation, you can change it up. As long as you do it to both sides, the exact same thing to both sides of the equation. So look over here on the left. Don't we really have a fraction here? Isn't this really all over 1?
Oh, yeah.
Okay, so we have a fraction on the left and a fraction on the right. Now notice a couple things. There's nothing added to the fraction, right? It's a fraction. There's nothing added to the fraction out here, right? Okay, so because of that, because we have a fraction on this side and a fraction on this side, we can actually split the fractions as long as we do it to both sides of the equation. So I'm going to flip this side, that's 1 over x plus 7, yeah? But I've got to flip both sides, so now I flip this side, we have y plus 1 all over negative 2. I flipped both sides of the equation. Does everybody see? We've done it to equally to both sides of the equation, and now it's going to easy to, since y is on top, easy to solve. Yeah, what do we do to get y along? Good, multiply by negative 2. So when you multiply fractions, don't you multiply straight across? So we'll have a negative 2 on top, because negative 2 times 1 is negative 2. On bottom, 1 times x plus 7 is just x plus 7. Does everybody see how I put this side together?
Yeah.
And that's equal to, those divide out become a 1. 1 divided by anything is just itself, right? Or 1 times anything, same thing. So we have a y plus 1. Then what will we do? Okay, so this is how we would write it correctly. We have f inverse, let me show you. F inverse of x is equal to, this was in front, so we have negative 2 over x plus 7, right?
Right.
And that was minus 1, right?
Right.
So then minus 1.
No. Oh.
Okay?
Is this
Questions?
On our paper? Is that on our paper?
Yeah, you're going to do like many of those today.
Where's it at?
There's like a million.
Mm-hmm.
Let's do another one. I'm giving you these last two. These are the last two. Stay with me, then the rest of the time's yours, and I won't bring you back to me again. So we switch x and y. So we have y is equal to 1 over x minus 3 plus 4. We switch x and y. X is equal to 1 over y minus 3 plus 4. Subtract 4 first, right?
Oh, yeah.
So we have x minus 4, since we do it to both sides of the equation, is equal to 1 over y minus 3. Now, isn't this in the bottom of a fraction? Yes. We're dealing with the same issue, right? You want to bring it up, but you got to do it correctly. So don't we have two fractions? Yes. So if we do it to both sides, as long as we do it to both sides, we're okay. So do you see how I'm flipping this side?
Yeah.
And I'm flipping this side. So y minus 3 over 1. What's anything divided by 1, guys?
Whatever it is.
No? Whatever.
It's that thing.
Okay, so y minus 3 divided by 1. Isn't that y minus 3?
Yeah.
Now isn't it one easy last step?
Yep.
Add 3?
Plus 3.
Can I add the 3 with this stuff?
No.
So we have 1 over x minus 4 plus 3 is equal to 1.
FX of inverse right there.
Questions?
Negative 1.
Last one. Okay, last one. The rest of the time will be yours. So we have x is equal to, I'm switching x and y right here, right now, so we can just get through this.
Plus 4.
Okay, so what would be my first step?
Minus 4. Minus that sheet.
So we have x minus 4 is equal to negative 3 halves y. Now, some of you are going to want to say, okay, so I'm going to divide both sides by negative 3 halves. If you do that, though, you're going to have to be really, really good at simplifying it correctly. And you'd have to be able to divide fractions, which most of you don't know how to do.
Times by 2.
That's what I would do. Good.
Boom.
So Braylon was able to see, isn't this technically,
Plus 5.
okay, let me rewrite it so that you guys can see algebraically what we have. When we multiply fractions, isn't this the same thing that you multiply straight across? So when we have a negative 3y on top and a 2 on bottom. Everybody, do you see that?
No. What? Yeah.
Y divided by 1. When you multiply fractions, you multiply straight across. Negative 3 times y. Negative 3y. What's 2 times 1? 2. Does everybody see how I put that together? Because now isn't it more obvious on how to algebraically go about it? Like Braylon said, because we're dividing by 2, we're going to multiply both sides by 2. Now don't I need to put that in parentheses? Yeah? Okay. So we have 2 times x minus 4 is equal to negative 3y. Now what would we do?
Divide by negative 3.
Divide by negative 3. Now isn't y all by itself?
Oh, yeah.
Okay, now keep in mind, if this answer actually I would accept, but let's say I give you a multiple choice test. And what if you don't see that answer on there and you say, I know I've done this correctly?
Hey, you choose.
You have to be able, no, you don't just pick the one that you think maybe looks the same. You would say to yourself, I must be writing this differently. So couldn't we actually simplify this down a little bit more if we wanted?
Yeah.
So isn't it 2 times all this stuff? So I'm going to show you guys, you'll need this. 2 times, no, you'll need this. I promise.
What about that?
2 times x, right? And then minus 8. And then that's all divided by negative 3, right? So what if that wasn't even an answer? What if they rewrote it like this? Now, as long as we keep both of those divided by negative 3, we're not changing anything. So isn't that negative 2/3 x? And then what's negative 8 divided by negative 3? Positive 8/3, right? So plus 8/3. So if I wrote the answer like this, would you be able to convert your answer? Well, you'd have to be able to. We just went over it, though. Does that make sense, everybody? Can you do it?
Yeah.
That wasn't that. Did anybody have any questions?
No.
Yes.
I only have a question on the actual sign.
Okay.
Even ones that say instead of f of x, there's h and n and.
Hey, 116. You're actually finishing the whole back. So the whole back of the worksheet. Good.